Hey guys, we're continuing section 3.2, which is on linear and nonlinear functions. And last week in the last video, we ended with discrete domains and continuous domains. We said that discrete domains was a set of inputs that only consisted of certain numbers, like 1, 2, 3, and we wrote the domains out within these brackets as those specific domain values. A continuous domain would just be a set of input values that consisted of all of the numbers in an interval. So between 1 and 5. That could include a number like 4.0005. So it was all values between 0 and 1. It's continuous when you can't pick your pencil off the paper to continue drawing the line. In example 1, you have to pick it up 5 times. In example 2, you don't pick it up at all. Okay, so that's discrete versus continuous. So we're going to start with this application. It says the linear function y equals 15.95x represents the total cost, y in dollars, of x tickets for a museum. And then it says each customer can buy a maximum of 4 tickets. So think of maybe you and your family. Let's say you're a family of 4. You might take your sister to the museum. You might take your sister and your mom to the museum, maybe just your dad, or maybe all of them. But the maximum number of tickets you would get for you and your family is 4. It says find the domain of the function and is it discrete or continuous? Let's start with discrete or continuous. Think about x, because we're talking about the domain here. Are they just specific integer values, or is it a continuous set of numbers? X represents the number of tickets you're getting. You can't get 1.5 tickets. You can't get half a ticket. So this domain is discrete because we're only looking at specific values. So the domain in this case would be I either get no tickets, 1 ticket, 2 tickets, 3 tickets, or up to 4 tickets. We said this is discrete because we have specific values. They're non-continuous. Then it says graph the function using its domain. Well, the domain only gave us x values. So in order to graph a function, we need coordinates with x and y values. So we need to plug in each of these domain values to get the output, the range values. I suggest you make a table with x and y values. So we know the domain is 0, 1, 2, 3, 4. And we want to find the y values. So in this case, when you plug 0 into the function, we already have our function. Y equals 15.95 times 0 is 0. The next one, y equals 15.95 times 1 ticket is 15.95. Notice that that can give us the cost of 1 ticket. That number in front of the x is a rate. If one person costs $15.95, we know 1 ticket is that much. So continue to do this for the second ticket, the third, and the fourth. So pause the video and finish finding those values. Okay, so now those are your values. We are going to graph these values, and if you have graph paper, great. If you don't, at least estimate it. So I'm going to draw my ticket values are 0, 1 ticket, 2 tickets, 3 tickets, and up to 4 tickets. And I'm going to estimate the rest since they become larger values. So I'm going to go by tens here due to the space I have. If you can do more, great. $10, $20, $30, $40, $50, and I'm going to extend that. $60, and we'll go up to $70. And then estimate. So 0, 0. 0 tickets costs, whoops. 0 tickets costs $0. 1 ticket costs $31.90. 3 tickets costs $47.85. So we're about up here. 4 tickets cost $63. So somewhere up there. Notice one of my points are kind of off, and that's just the way I estimated things to be. Actually, I skipped a value as well. So my 2 tickets should have been right here, 31 something, and my 1 ticket was about 15.95. Makes more sense. It's a linear function, so it has a linear shape to it. If I connected those points, it would be a line. We're not connecting them because it's a discrete domain talking about specific tickets. Okay? Go ahead and read the next problem. You can try it on your own, or you can keep the video playing to learn about it a little more. So the linear function m is equal to 50 minus 9d represents the amount m in dollars of money you have after buying DVDs. Find the domain of the function. Is it continuous? Is it discrete? And then we want to graph again. So we have a function, and it's representing how much money I have after I buy DVDs. So if I have a certain amount of money, the more DVDs I buy, the less amount of money is going to be in my pocket. So you have to consider that the amount of money you have will decrease depending on how many more DVDs you buy. Always think about the situation before you start the problem. Can you buy half a DVD? No. We can only buy specific numbers of DVDs, and we can't run out of money, because once we run out of money, we can't buy any more DVDs. We're going to have none left. So let's label this function to help us out. That's m is going to be how much I have left. This part right here, the D stands for number of DVDs. The number in front of the variable D is the rate per DVD, meaning the cost is $9 per DVD. Pause the video and think about what this 50 represents if it's subtracting 9 per DVD that I plug in. So you should have made a little guess before we continue. This right here is going to represent how much money I begin with, and I'm going to subtract $9 each time I buy a DVD. So let's find out what our domain is by plugging in these values and finding out how many DVDs I can get before I'm out of money. So I can get no DVDs. If I plug no DVDs in, I have the amount of money I started with, 50. What happens if I plug 1 DVD in? I'm going to have $41 left. I'd like you guys to pause and try this until you have no money left. Use the table and then check your answer when you're done. All right, so there are the rest of your values. Notice when we got to 6 DVDs, we have a negative value. We can't have negative money. So we want to cut that out of our graph and our domain. We can now easily list the domain values. We can only buy up to 5 DVDs, and our domain is the X's. So I'm going to list my domain is possible number of DVDs. So 0, 1, 2, 3, 4, and 5 DVDs. I'll have $5 left by the time I get there. Now, is it discrete or continuous? This function's discrete, and it is discrete because we can only have whole numbers of DVDs. We can't have half a DVD. We can't buy half a DVD. So we have whole number DVDs, or the domain involves whole numbers. Nothing in between, so it's not continuous. Like I said, there's no halves, there's no quarters. Now, when we graph it, you can estimate again. And if you have more space on your paper, which you should, try to make it more spacious when you graph these coordinates. If you have graph paper, that would be a great idea to make things neater. We'll definitely need it later on. Sorry, that should be 1, 2, 3, 4, 5 DVDs. 0 DVDs will have $50. 1 we will have 41. 2 will have 32. 3 we will have 23. 4 we'll have $14 left, and 5, it's a little off, we will have $5 left, and we don't want to go negative. Don't connect them because we can't have a DVD quantity in between those whole numbers. We'll save that one for a warm-up. Let's look at number 9. Is the domain discrete or continuous? Explain. Input is the number of stories of a building. The height of the building is the y value. So when we're talking about stories, we can have half of a story and it would build more height to the building. So while this shows whole numbers, we can say between 1 and 2 stories would be about 1.5 stories of a building. And we can talk about the height of the building around that. So yes, you can have a part of a story when you're describing the height of a building. So this function is continuous. We will save this one for a warm-up as well. And this last one, discrete or continuous. We know that specific values gives us this discrete function. So graph A is discrete and graph B is continuous. It is a line. There are values in between. If I drew this line, I wouldn't pick my finger up off of the paper. Okay. Let's try the domain for B again. We've done this before. We'll do it actually we'll do it for B. So remember, the domain of continuous functions requires you to look at all the possible x values. So we're looking at those numbers, but we're blocking it off to the leftmost part of the graph and the rightmost part of the graph. And you're asking yourself, what's the smallest and the largest x value that my graph touches? And that goes into an inequality where x lies between, we use the less than or equal to symbol, the smallest value, which is 0, and the largest, which is 6. For the range, it works the same way, but your eyes should be looking at the y values. If I wanted to block off this graph, I'd want to go from bottom most smallest value to the top value. And where do you block it off? You're looking at the y values now. We block it off at 0 and at 6. The only difference now, you use a y variable for in between and your smallest and largest number. The domain and range of a discrete function, you can list the values. So you always want to list the coordinates here, and all you're doing is in the brackets listing all the possible x values and all the possible y values. There's no inequalities in a discrete function. So we went over those a few times at this point, so we'll practice it a little more in class.